Hello everyone, am I audible to you? Good morning. Hello, am I audible now? Actually, mic is connecting, that's why. Hope my voice is audible to you. See, K-means clustering we are going to work on, right? And today we are going to end up some content, and even I have created a near about 100 questions related with the machine learning, so that is also we are going to work on, right? That content also I'm going to share with you. If suppose new points you will get into the machine learning PDF file, no, so you can go for that checking work of this. Yesterday I have given you one example, basic k-means clustering work. You know what is the major work related with the k-means clustering? K-means clustering is an unsupervised algorithm. Is it correct? Yes or no? Let me know into chat. Yes or no? Right. So if suppose if I'm working with the k-means clustering, then there is a no labels. No labels means there is a no dependent variable. If suppose there is a not an any kind of dependent variable, just consider it is like we have to create a label, right? So just imagine if suppose if I'm thinking about I'm creating new notebook here, right? And let's go for some implementation. Okay. So side by side, I'm just doing import pandas as a PD, import numpy as a NP. So I'm implementing k-means. So let's check out the examples. Same content I'm going to take. So we are going to make a categories of mall customers, right? So we have to check and we are going to find out the categories. Categories is not in finding the categories, we are creating a categories of mall customers. Okay. So our data set is in what happened? Okay. So on the basis of annual income and spending score, we are making the categories. So we are not taking the customer ID, gender, and age. Only we are taking the three and fourth columns, the third and fourth column, and passing into the X. Here we don't have dependent variable, then X is your observation value. So on the basis of your observation value, you are creating some categories. So it depends upon you how many categories you want to create. See what I'm saying. So you can pass these values into where algorithm. So how can I do this work? This is important. So let's go and implement this one first. Okay. First, we are going to find out the optimal numbers of clusters, means how many clusters we have to take. Is it correct? What I'm saying? First, we have to know how many clusters we have to take. So that purpose, first we are going to implement elbow method. Okay. So let's go for this one. Mm, so that purpose, I have to pass from scalar dot cluster. Okay, we have to find clusters now. That's why I'm doing this one. Cluster. Okay, and import k. So k should and means should be big. Now, first initialize the list for some you can take an means we are going to pass the data now. So initializing the list, you can pass any name. So I'll take here R is equals to list. So we are passing the data into that so that we can get it easily. So now initializing the list for getting a data observation values. Then we are going to find out the for I in range. In that range, you can pass how many times your loop will execute. So I'm just doing here 1 comma 11. Okay. So k means, so I'll just pass in one variable name, and km means into the bracket you have to pass how many clusters you want. So you can pass, it depends upon you, but I'm passing n clusters. Okay, n clusters and the count of I. So how many times that loop will execute, no, that much time. Okay, comma, initializing the method of k-means cluster. Okay, initializing the method of k-means. So that purpose you have to pass k, sorry, k dash, see, k dash means plus plus. So this is a method to fetch a k-means cluster. Then you can pass random underscore. You can pass two. It depends upon. Now we have to fetch k-means dot fit the method of x, which x that we are created here. See this one. So you can pass here. So I'll pass a small here. Okay. So once I get this one, no, we have to pass this data. See what I'm saying? This data k-means clustering because we have trained our k-means and that into, yeah, you have taken only this one, annual income and spending scores. Wait, I will show you. Fifteen and 13. But now what the point? It depends. It depends on how many columns you want to take. You have to convert your values, right? Because your machine learning understand only numeric. So it depends upon you how many columns that affects for getting output. So which, if you want to output something, then observational values are important. So it depends upon you. So R dot append, you are appending because that R is my list, no? So we are passing here k means. So k means is nothing but yes, this one. Okay. Dot. Here I'm passing inertia. So this is the question now. So what is the exactly inertia, right? Now. So what is inertia? Inertia measures the how well data set was clustered. He just understands and checks the how well data set was clustered. Means we are going to create a clusters now. So then all the data will go through the k-means. So data should be in the position and data should be in the well manner. That's why we have assigned there k-means inertia method. So that if suppose once we assign k-means inertia method, it's it's kind of, it's kind of suppose the way we have used KNN, in that KNN we assign the distance matrices, Euclidean distance and no, Euclidean and Manhattan, right? Manhattan distance. The two distance matrices that we have implemented there. The major work about inertia, he will check the distance. Why? Because we are gray. KNNs we have implemented KNN actually. One of the session. I will check that one also. Rahul. Okay. So Euclidean distance. Euclidean distance is nothing but the distance between the two consecutive points. See what I'm saying? Distance between two consecutive points. Wait, I will show you what is the exact meaning of this. Yes, yes. The quality means he will check the. It's kind of the every observation points are properly maintained or not, because you are creating suppose you are passing of 5 clusters and every one is an unique, no, So 5 clusters means one of the A cluster you are taking, the A cluster maintains his positional values, means whatever the observation he selected, they are correctly positioned or not, because here the word of centroid concept is there, right? Centroid concept means every cluster has his own centroid point. Centroid is nothing but middle, mean of middle of the point, right? And all the observations are attracted towards the his means itself own centroid points, means clustering points. So I will show you that is. So the major point is that the distance, right? Wait, I will show. Is it visible? So before centroid point means how many times it will keep shuffling the data to get the centroid. Centroid is you are passing their for loop, no, that's why that checking each and every time. So 10 times your data is means it's kind of looping and looping and looping, right? To understand each and every observation values. First, this content we are taking for understanding how many clusters we should have today. So that's why. So I will show you on the basis of 10 clusters. First, he will show you the first curve and all, that's why. But now I'm just showing you the Euclidean distance. See, Euclidean distance is nothing but this blue line. So blue line is nothing but the previously I have said that Euclidean distance is nothing but air distance, the one point to another point. Suppose there is a huge numbers of observation values. So every time he will check the distance of each every distance between two data points. Not only two data points, every observation point distance he will check. So now we are considering only Euclidean distance because K-means clustering uses Euclidean distance to arrange and measure the distance from centroid, see, from centroid to other observations. So centroid is nothing but suppose one cluster is there. Wait, I will show you another one example. Side by side, we can consider, we can go for the some important topics as well. K-mean works means Manhattan and K-means with the Euclidean. KNN works with the Manhattan as well as Euclidean as well. K means clustering is Euclidean distance. Euclidean is nothing but its distance between two consecutive ones. It's kind of checking the air distance. And K means using the distance, means he will check the Euclidean distance to centroid to from centroid to respective observation values. What I'm going to check here, Euclidean distance. I forget to what is the what is this distance of data. Distance of data means observation values, because you are making observations are there, no? Wait, I will show you. Now I got what I'm going to tell you. Sum of square distance between 2 points. Yes, yes. See, this is an clustering point. So this middle point of this one, the middles are there, no? These are the centroid, right? Calculating the centroid is important first. So understanding purpose, if suppose how many centroids you want to create. Centroid is nothing but your cluster. So how many clusters you want to create? If suppose if you say to three, then you will get in three centroids. If you pass the five, clusters, then every cluster has its own centroid. So where there is a data is collection, no, means data is spread all over the area. So because of centroid, he will check for the distance of each observational values. So where is in blue? If suppose the data is now clear, but if I'm thinking about one example, wait, I'll show you. I'll give you one more example. See, this is a mixed format data set, right, Rahul? And we have to make a three clusters, but it depends upon you deciding how many clusters you want to. That's why we are implementing the first. Still, we haven't implemented the k-means fully. The code that I'm implementing, no, this is deciding to how many clusters you want to create. Because here we don't have any kind of labels. No, here even your data observations points also not given how many categories are there and how many categories you want to create. So whatever the code I'm implementing to show the how many clusters you want to create, how many clusters it would be there, right? So now this data is going to be look like this one. So how can I create a red, green, and blue? How how can I decide that clusters should be there? So deciding a clusters that comes into the where this code and creating a distance between the means finding the distance between that code is different that I'm going to create after this one. Okay. Now the point is that if suppose if you have decided to make a cluster, see what I'm saying. If you have decided to make a clusters, what is the major point? If suppose even algorithm don't know about this is a red or this is a green or this is a blue. If you pass, he first find the similar kind of data observation values, finding the similar data points. So he's trying to make a actual three clusters because you have already said no. If suppose if you apply this code, wait, I will implement this one first, and then I will show you the major point here. Okay, I will implement this because that's why without this will you will not get it easily. I have to implement here one more library. How it is. That's why, sir, just wait for this one. I will tell you. Because I will go for the step by step. Directly question will come. No? Definitely getting problem. See, now we have the simple point here, right? And wait, I'll show how many clusters you want to. This is the elbow method, okay? This is elbow method. So I will just pass the some title in front of you so that you can get it easily. PLT dot. This is nothing but X label. While loop is only from, it depends upon, it depends if you want to pass 8, it depends upon if you want to 10, it doesn't matter. Yesterday, the way I told you, the first curve is important here, the curve that you want to take. Okay, number of clusters. See, the elbow method. This is we are implementing elbow method. It doesn't matter. Okay, now elbow method shows you the number of clusters. How many numbers of clusters you can take. The first, see, it depends upon your observation. Now it depends upon now. It's up to you that how can you decide this one, because see, the number of clusters you can take here first. See this one, or you can see this one. You can take 3 or you can take a 5. It shows you the curve, the first curve. If suppose if you are getting a kind of this one in the first curve, then definitely it will comes to the 7 or 5 or 3, right? He is showing you data behavior of this. So that's why this is an elbow method graph. Okay. So it depends upon now 5 methods, means 5 clusters you are going to take. Can it be disconnected? Means only we are deciding to clusters count, because many questions will come. No, so how can I decide the cluster? So this is we are passing into the elbow method to get a cluster count, means average assumptions of cluster count, right? This is nothing but it's kind of finding the optimal numbers of clusters with the elbow method. But major point is that it's not a meaning of only 3 to 4, 5 you can use. You can use the here this one also. It doesn't matter 8 or 6 one also. No curve which is not connected one after another. Yes, yes. He is only giving you the points. It depends upon you that the 3 clusters you want to use or 4 or 5. But data behavioral part, he's showing you that here are the data behaviors and changes, right? That's why I'm deciding to go for the 5. Or you can go for the 3, or you can go for the 8 as well, because every point it depends upon you that you can choose the count of clusters. Okay. So little bit further, first implement. We are going to implement this one, and let's see what will happen. Okay. Range, how do we choose? For loops range, it depends. You can check. It depends, not an issue. 5 or 10. If suppose if you increase the more loops will get. This loop should execute till all the data points. Yes, yes. Total data points, he will take all the data, total data points, not an issue. Because you are passing X, no, that's why. K means is equals to KM, K means into the bracket, clusters, deciding with the 5, comma, init is equals to. Now you are passing this K dash means plus plus see the variance is there a lot. X and Y axis not making difference in making clusters. Only we are getting the observational values, observations. We can take this one, not because both are different. No, this is when we are deciding the categories, means it's kind of 4 or 5, and these are the continuous observation values. It's kind of linear regression, if you think about it. Means assigning the values, it's kind of. Y predict K means dot fit, and into that you can pass fit predict or fit predict. You can pass X. Init is the method. Init is getting, it is an K-means clustering method. As init is nothing but initializing. You are initializing the method of K-means. Parameter you can say, not a method, parameter. See, how many questions we have asked total? 200 rows. So X data is in 200, and that data is divided into the 5 clusters. So check out the cluster count as well. So how many clusters count is there? 0 is there, 2 is there, 1 is there, 3 is there, and 4 is there. So this is a total 5. So we have assigned no n clusters equals to 5. So that's why we are getting the 5 clusters, and the whole data is divided into this one. So it's kind of your Y column. We have created the Y column, means if suppose if you're thinking about classification algorithm, supervised learning, label data set, no. So you can create this data and pass as a column into the that mall customers. Is it correct? What I'm telling to you. If suppose new observation point is coming into the asking to the category, no. So which category is mine? So that time no need to go for this k-means clustering. You can pass into the logistic regression or SVM support vector machine, means support vector machine or random forest, and get the prediction. Are you getting my point? What I'm trying to say? Why this is important to understand? Means you are creating a labels for that observation values. Is it correct? If suppose the prediction the way we got, no. So you are deciding fit and predict together here. Yes, yes. You are training as well as the prediction as not understand logic behind the range till 10. Which one? This one. Actually, your loop is executed 10 times. It doesn't matter, you can pass 8 or 10. It doesn't matter. But your whole data, see here, your whole data is fitting into the k-means how many times? 10 times. Right? And you are checking your data is correct or not. Means observation, how many, means suppose check out here data. So you are passing number of clusters. So suppose 10 times execution, you are passing the n clusters is an I. So first k-means is deciding if suppose if I'm passing the whole data observation whole observation values into the loop, he will give you the all over work, means till he is considering the 10 clusters are there. right? So 10 clusters are dividing. So where there is a little curve, there is some data values, data behaviors and changes. So here is also changes and here is also changes, right? So you can consider it depends upon the 10 clusters. Means you already implemented your k-means here, not an issue. But with the 10 clusters, you are assuming the 10 clusters. And every time your 10 clusters with comes with the every cluster means see just imagine once he executed the all data goes into the one cluster, he will check second time second cluster, third time third cluster, but whole process is repeating continuously. Are you getting my point? Because suppose the first will go here I, so cluster 1 is there, your cluster 1 is learning the x data. Now got the point. So every time this is executing. So each and every cluster is learning his same data continuously. And then we got it this one. So where there is an suppose the third clustering point, the data is changes. The fifth clustering time, the data is changes. Behavior is changes. That's why that's why we are deciding to go for the five clusters. Five clusters. See the count, see the unique values. How many unique values will be there? Because n cluster is equals to 5. So 2 is there. See, 2, 0 is there, 1 is there, 2 is there, 3 is there, and 4 is there. So how many clusters it will be? 5. Now got the point. So you can take this data. See what I'm saying. What is the sum of Euclidean distance of each point to its closest centroid? Can we what? Can we check that? No, actually here that type of functions they are not given us any kind of. They haven't given distance. So that purpose we have to do something here. If we suppose try to print in between that, no? So we can't check errors. Yeah, we can't check because that's why we implemented the graph here. So some kind of errors will definitely happen here. But errors means what? Actually, it's kind of how can we get the error? Error is nothing but it's kind of changes the changing or changes between the data points, right? Observational values. Can we predict the values without knowing this distance? Uh, Without knowing the distance, if I'm thinking no, distance means these values without knowing this one or without knowing can we predict the without knowing this distance means can you tell me from centroid? No, you have to check for the distance. No, you have to check. See, if I'm plotting the data, see what I'm saying. If I'm plotting the data, just consider this diagram. If I'm plotting the data, you are going to find out the similar data observation points. No, if suppose you will get in some data observation pair. See, this is observational values. Okay. If suppose if you have decided on the basis of LO method 3 or 5 clusters, then definitely you will go and implement the centroid points. Sorry, you will go for the creating clusters points. Randomly, you have decided to check passing the clusters, not an issue. But once we get a similar data points, he will choose any of them. He will check for the every cluster points. Okay, I will create a draw something here. See here. If suppose if you are getting some observational values, similar data observation values, this kind of observation values, okay, this kind of observation values, what will happen? He will check the distances of each and every observation values, like that, each and every one. But not only checking the observation values, he will check the average observation values, and then he will check the distance of average distance of the observation values and creating the centroid, means creating the mean. What is the definition of centroid? What is the definition of centroid? First, we will clarify that one, right? That's why that is important. First, we need to calculate the distance between initial centroid point with the other data points. What is the exactly centroid is nothing but we have to calculate the distance between the initial centroid point. So initial centroid point is nothing but randomly you are picking up any kind of values, and on the basis of that random values, he will check that a similar kind of data points to the everyone, right? Randomly pick up the unique values and finding the similar kind of observational values. So randomly pickup means initial centroid, any kind of initial centroid values. Creating a centroid point is nothing but you can calculate the distances, okay, and create a meaning center point. For checking purpose, if suppose at the end, if I'm creating like this one, so how can I get the correct distance? Why you say similar? Similar means it's on same behavioral point, because you are creating. You suppose on the basis of observational values, I'm just thinking about this example in front of you. Suppose red, green, blue, red, blue, and suppose yellow is there. So he will find out the red, red only. No, he will find out the green, green, or he will find out the yellow, yellows. So always, if I'm creating a cluster is collecting his own behavioral parts, people, right? The each cluster is on the basis of his is suppose in the observational points, in our current observational point, we have the unique data, not an issue. But you are creating five clusters. You cannot create unique peoples are there. That's why I will create each one for the same, each one for the clusters, means individual cluster for each one. You cannot create. You already decided five clusters I have to create, and whatever the thousands or millions of peoples, you have to slice down into the five clusters only, right? So in that, each and every cluster will find out the some observational values that makes the similarities between the that means his own, means the cluster 3 will finding the similar data points, similar behavior observations for them. He will attract them, right? Even same for the blue, even same for the yellow colors as well. The first thing, see how the centroid will work. How the centroid will work. First, he will calculate the distance of initial centroid points with the other data points. Second, he will go for calculating the mean value of cluster, that whatever the created, no, whatever the clusters that directly we have implemented, the five clusters we have implemented, and he is that every cluster is going to find out the observation values. Okay, then calculating the mean values of the clusters that created, the new centroid points will be created. Now, see, if randomly you are creating a centroid, and there is an you are putting a random centroid point, means anywhere into the data. Just a minute, I'll annotating something here. Suppose your target concept is this one. Okay, target concept is at the end you want like this. But when centroid, when cluster will create, when any cluster will create, your centroid will be initialized anywhere into the centroid, means anywhere. You can decide anywhere into that. But whenever he find out the similar data points to the each other, see what I'm saying. Whenever he is going to find out, whenever he is going to find out the cluster point from each observation values, every time, every individual loop, he will find out the new centroid point, new center point. So he will make some nearest, and nearest, and then he will come up the middle of the area. So directly he will not go for the middle of the area and finding the similar observation values, right? He will first enter into the anywhere into the cluster and then finding the positions, distance from the similar data points, and then go for that. Are you getting my point? He is not entering directly for the centroid central position of the cluster. First, take the random position, finds the observation values, check the distance, and create a new center point. Then and again he will go for the checking for the observation values, check the distance, creating the new center points. So every time this concept will repeat and repeat. Means it's kind of your your cluster is moving around each whole graph every time. Are you getting my point? Every time your cluster will move around. Why? Because your center points also changes. No, the way he is going to find out the observation values, every time he changes the position, and center points also changes. At the end, we are getting the output in the middle of the center point, but the structure of the getting center point is initially isn't different. See, the way we are getting the clusters here, means categories here, is it possible to add as a column of Yprid? Yes or no? What do you think? Is it possible to add as a column? A real problem scenario is an you will not get an labeling. So you are creating your labels here, right? Because your data does not have any kind of labels. So you are creating your own labeling. So clusters gives you assumptional clustering count. So you can make a bifurcation, means you are getting a dividation your observational values. So this is the only one problem that we can get into whole journey of machine learning, where there is a no labels for the prediction purpose. So if you want to go for the prediction, then how can you go without prediction values, without any? If suppose credit card data is there and you don't have an their target column, means true or false, means fraud or not, then how can you go for the credit card, fraud or not? That time you are going to use this k-means clustering to understand credit card fraud or not, means creating a target column, and create a target column, then you can go for the prediction for the supervised. If suppose there is an y, don't have an y column, you have to enter into the k-means and apply first k-means on the observational values and create your y column, and then you can go for the label dataset. Now got the point, everyone? The question is that we are creating a, now we have in created the y predict, no? So how can I pass as a column this y predict column to the observation value? This is a data set and we are going to create a new column. How can I create? concat. Is it? Is it possible? Because this is ypred is your numpy, no? How? Which one you will consider this one? No, you have created add new column. Add new column concept. I have already teached you. How can you create add new column? Yes or no? Yeah. Yes, sir. Actually, but what is the drawback of here? What is the drawback? Because you cannot trust on this concept. Because means if suppose if you are deciding to go for the credit card uh, or diabetes or heart disease, you are considering only two categories, no, true or false. And suppose if you are passing your only observation values into the k-means, and suppose he is giving you some 4 to 5 clusters, are you getting my point? Then how can you believe on this? So very rarely you will get this kind of concept for the interviews. Real time scenarios, we cannot use this. Tell me how to create column. Can I create new column here to add there? Using insert. Already you have used no using insert column. Yeah, that's why that's the actually this is uh, that's why the k-means has in limitations. If your data is in huge and column is in huge, definitely it will go slow and not trustable concept. Is it correct? See, clusters, the concepts are same. I have to check other algorithms as well. Only k-means clustering is there for implementation, ma'am. If there is any other algorithm for implementation to tell, I will definitely go for that. But this is major for understanding. Is it possible to go for prediction if you get the clustering concept? Now you got no this column and data set is there. You can store this into the new CSV file. Wait, dot to underscore CSV into the bracket. You can pass. Uh, I'll pass the location of this one. Hmm. Small clusters. How to interpret the number of numbers in clusters column. Numbers in clusters column means you're asking for the how did we get the this one? Wait. What does mean by 0, 1, 2, 3, 4? These are the cluster count. These are the cluster count. Here we are making the clusters. Clusters are nothing but groups. Okay, group count is there. So which observation point is belongs to 0 cluster? Which observation point is belongs to 1? This we have created here. PD dot oh sorry. Cluster 0, cluster 1, yeah, till that cluster 4. That's why we are getting the 0, 1, 2, 3, 4. That's why. At the end, we are creating here a target column. But we can't believe on that target column. No. It depends upon you that even why this K-means is saying if you don't know the target column, if you don't know the labels, see, if suppose there is an animals data, see what I'm saying. Okay, this is important example. There is an animals data and observation values are there, means your data points are there, no? So how many legs are there, color, animals colors are there, tail is yes or no, it's kind of there, and you don't know the labels, you don't know that which these data observations are there, and you don't know that this observation is belongs to that animal or not, means you don't know that animal names, and then how can you predict which observations are belongs to which animal? Are you getting my point? So while only watching to the observations, how can you decide this is an horse, this is a dog, this is a cat? Can I check the data inside a cluster? We have to check for that, sir. The question is good actually, but we have to check, right? But are you getting the question? Are you getting the concept behind this one? The way I have tell you the example of animals means you have an observations features of animals, but you don't know that that feature is belongs to which animal. So on the basis of that, you are creating clusters. Okay. So wait, the questions is why not I print here? Mhm. Okay. Length is in 10 means because 10 times this is executing. No? So data is assigning into the R. The first cluster is saying that 26,000 means this point. It's kind of this. Then this is 10,000. The first curve we got, and then 73,000. This is not in 73,000, right? This is fourth cluster here. So this is maybe 73,000. 1, 2, 3, 4, 5. This is fourth. This is 5. Then, so every time only data we are getting, right, sir? Only we are getting. On which basis cluster 0 is created? On which basis? So that not only we are deciding about zeros, every clusters we are deciding. So every cluster is finding the observation values. So why I'm always using the similar word is there. So he's creating his own observation. He's finding his own similar kind of observation values, right? So not only cluster created with the zero, not there is an 5 clusters we have created, right? So everyone has a different behavior. There is a possibilities that more than 7, more than 10 unique clusters may create it, but we have assigned only 5 clusters. That's why your whole data is divided into the 5 clusters. Okay, means it's not in like that. If you pass a 10, then definitely your whole data is divided into the 10. It's not like the 6, 7, 8, 9, 10 will goes into the 0, 0, 0 observation values. We have assigned there 5 clusters. That's why they have divided into the 5. And every cluster will find his own observation values. It depends upon the elbow method. That's why we have assigned this observation values, this code. If you want to find out how many numbers of clusters we have to take, you can implement this code, pass the values here, text data, and decide your clustering count. Are you getting, ma'am? So this always, first you have to, can you explain again? You have to pass your data. This data, your x value, you can pass into this format in this code. Okay, and you are implementing 10 times. You are looping your whole data 10 times into the k-means clustering, and that data, your values, you are storing into that. So that purpose, we are getting the some amount of, this is elbow method, no? So what is elbow method does? What is the work of elbow method here? What is the work of elbow method? He will show you the finding the optimal numbers of clusters. Using elbow method, he will show you finding the optimal numbers of clusters. Okay, so once we plot your data on this one, on this elbow method, you will get a number of clusters. So first time, first he decided to go with the 10 clusters. That's why we have assigned n underscore clusters equals to I, right? So how many times loop will execute? No, that much your clusters will get here, right? And after implementing on the 10 clusters, he will give you the some line chart about that. And the first curve, the changes, the behavioral changes of the curve, that makes you to choose a count of that. So, and the third cluster, the behavior is changes. In the fifth cluster's behavior is changes. So it's might be chances to take third three clusters, or you can check with the five. It's not necessary to go with the three or five. It depends upon you. But elbow method gives you two trustful chances to choose this one. You can trust on this one. Okay. Now, wait. The way we are getting the time side by side, I will show you, tell you some questionnaires as well, because that is important. I'll show you some content as well. Just a second, give me a second. I'll download that file. Is it visible? Hello. So I think the questions that I have made here, huge. See what is array and its types. So you will get a list, tuple, set, and dictionary. Right. This is the notes that with the question answers we got it here. Okay, some functionalities as well. The list has an len, pop, append, insert, concatenate. Is it correct what I'm showing you? It will help you to understand each and everything. Okay, difference between list and tuple, difference between set and dictionary, keywords, and so many things. The Python questions actually only we got in 7. Oh, okay. 33 questions. See, these are the questions and answers I have implemented here. So hidden means actually answers are there, but when you get the answer, means when you get the PPT, PDF, you will get all the contents easily. See, almost till ANN, support vector machine, what is the new bias, okay, voting classifier, so all the contents that we have. Is it like a data between 5 to 10K gone to the clusters 0, cluster 0, 10K to 5 clusters 1, similar data group together? Uh, no, actually. Every cluster will get an unique observation values, not like a whole data with the each and every cluster. So you got the point. Every time, every cluster will get an unique data. Yes. So here, how many questions that I have implemented? Almost, see, 115. Have we done prediction on the clusters yet? No, directly you can go for the prediction, not an issue. You can do easily. You can pass this after creation of this clusters. No, you can pass into where directly any of the random forest or prediction, any one of them, any supervised algorithm. But just this is an example to create implementation of this small customers. You can check for any random data set on no without passing Y column. Are you getting Rahul? You can take any data set like uh, what that like and you can take animals data. Yeah, is it possible to get an animals data? I think if we get an cleared differentiation data set, no, it would be best for that. I think. mm, Credit card or then credit card is heavy. If suppose Irish dataset is you do you know the Irish dataset? At the end, the clusters count. You have gotten Y column. Okay, prediction process. When will be the last session of this course? I will just ask to the administrator. Okay, because I'm just working on the contents that implementation. I think this one is an ending point, the machine learning, because this contains the remain. If suppose if something is remaining, that we are going to work on the ANN as well, right? So I'll ask to the team as about this one. If there isn't any content that important and to tell. Actually, SQL is there, no? Is it there? SQL is there, maybe. So one thing just I would like to tell you. Have you started the preparation on this one? What is the plan for the upcoming sessions? Can we have the clear agenda? Yes, I will share with you on portal as well. So whatever the contents that we are reviewing. Okay. Power BI SQL is there. Power BI, I don't know about Power BI. They have mentioned or not. If suppose mentioned, then definitely Tableau will be there. Statics point, the almost that with the concept we have covered the major contents. us a clear agenda. Yes, sir. Definitely, I will show you. Even I will share with you. Not an- Okay. Hello. Do you have the class agenda with you? Yeah, I have actually. This species I don't have. This species for the implementation purpose I have. But if suppose is there a, we can discuss with you, no problem. I have so many things. Now I don't have in this PC. That's why. This is my practical PC consideration. Wait, I will check for that one on other PCs as well. A team will share with you, no problem. Because if there isn't, okay. If not starting, can we explain the new best? If not starting new best, yes. Wait, I will take PPT as well. Now, as proposed, the one data set that we have taken, please share the question bank today. Yeah, I will upload that. I think today evening you will get that by uploading. The data set you want to go for. I'll take a data set here first. Wait. Yes, today evening you will get update here. I'm taking one data set. It is there in. Yeah, question bank is enough. No problem. Run this cell. Okay. If suppose there is any remains, no, I will update. Actually, um, 120 to 125 questions are there, but some of the gets problem. That's why I never added. But this is enough, not an issue. We can go for the quick implementation of new bias. We need to SQL and Python, Azure, language tables. Skill set is near, I believe, for the job. You will get it easily. If suppose if you implemented data analysis, the major thing is data analysis. In the data analyst post, or if you think about machine learning, no, your major target should to cover this analysis means NumPy and Pandas library is most important, and then prediction is in secondary. No, they will ask you some questions on you know what project you have implemented. If suppose credit card is there, no, credit card implementation from imbalancing cross validation techniques to till prediction means prediction till accuracy score. So if you know the life cycle of this one, no, definitely it will be easy to implement. You have to skilled with data analysis because these are the questions, and Python functions are also important. See what I'm saying, Python functions. What about the problem based different theorem, statics, mathematical computation with the solution? Mathematical computations with the solution means mhm. If suppose you will not get count of means concept of the mathematical execution. The library is most important. If suppose if I'm taking the mean, median, mode, these are the things, the mathematical things. But even these are the things that given into the library, right? Where is an Irish? So can anybody tell me about label encoding? How can I do the label encoding on this one data set from sklearn? Which library I have to use for the label encoding? Can you tell me from sklearn? one hot encoder. You can use one hot or none because this is iris data set, iris flowers data set. No? So L1 is equals to spaces. Yeah, libraries are enough. Implementation is important. The last spaces you are going to find out. No? So from sklearn dot model selection import train split. See, this Google Colab is very fast. The recommendation comes easily. Test comma y train comma y test is equals to train underscore test underscore split into the bracket x comma y you are passing comma test price is equals to 0.12 pass here comma and state is equals to 2 x train x test y train y test and this one. Okay, from SQL dot you can now it's up to you that which point you have to be constructed. SQL dot name. See what I'm passing new underscore price. Okay, import Gaussian new price. And then C1, I'm just creating a C1 and C1 dot fit into the bracket. You can pass X train comma Y. Okay, so now Y trade is equals to C1 dot predict into the bracket X test. See the prediction shape we got it all the means spaces we are going to predict no. So spaces we are going to predict is nothing but species. Means this flower is Iris centosa or Iris. Here we have Virginica or versicolor. Three categories are there. Okay. So observation, while you are passing the observations, you are going to predict the species of that flower. Okay, which species of that particular iris flower. So if you pass, suppose I will choose any one of them. Okay, I will choose this one. Okay, you should have to give what? Same answer. 0. Okay. So I'm going to do one thing here. How can we do the reverse? How can we do the fit inverse? Is it correct? Inverse transform. Is it correct or not? Can you tell me about this one? 15 slide. These are the observation values. See. I got you. This one. Part 1, 2, 3, 4, 5, and on the basis of this one. Now got the point. Specific, yeah, specific. And I got a 0. So what is a 0? That's why what I'm going to do, inverse transform. Is it code is correct? My code is correct, inverse transform. Tell me, can you tell me about this one? Code is correct or not? If code is correct, then I can execute. Yes, no? Yeah, it's correct. Okay, now I'm going to see. Actually, the previously we have to print that as well. Means previously the way we executed, no? That time also we have to execute it here. Wait. Okay, see. The sequentially we got an 0, 1, 2. Okay. Sequentially we got an 0, 1. And the sequence that we have in the last Sentosa, versicolor, and Virginica. So we are getting this Sentosa. If suppose if you want to pass one hot encoding, it might be good because you can pass yourself for the particular Sentosa, you can pass 0, versicolor, you can pass 1. It depends upon you know. In the label encoding, you are getting the random numbers for that. So that's why might be getting chances to confusion. But I'm using label encoding. You can use one hot encoding or mapping concept. Okay, it is easy to implementation to understand to which category we got it at the end, the prediction purpose. Here we got in Sentosa. Here we got in Sentosa 0. All right. So why 0 we? Where is in that actually? This one, 0. And the first that we got in Sentosa as well here. So our naive algorithm giving good answer. Okay. Hope so. You gotten through this quick explanation of this naive bias, but you have to do an Not only this, because I'm using a multi-classification, no, do not go for the binary classification, go for the multi-classification only. Because NeoBase is supporting for the multi-classification more. So better you just go for this one. And for the interview sessions, if you're applying for the jobs, then please go for major thing about analysis and prediction. If suppose if you are implementing any diabetes or any credit card for detection, heart disease, then definitely go for that, right? How to evaluate, improve, and develop for the real use. Actually, evaluate means it depends upon us that which algorithm we have to use. If suppose any, if you are this means discussion, if you are discussion on the basis of your algorithm, any project if you want to implement and choosing the algorithms and you want to improve the model accuracy, then definitely there isn't many chances. If suppose there isn't many chances to go for the improve the accuracy of model. How? That is an there is an imbalancing techniques are there, cross validation techniques are there. Even in now after the cross validation technique, we have used ensemble technique as well. So ensemble is one of the best one. If you don't know ensemble, please go for the previous one. Even we have spent near about 2 weeks for the ensemble techniques. So that is random forest 1, 2, and 3. That is most important. For naive model, model purpose. If suppose if you want to improve and means check the accuracy, I always said that accuracy score is an secondary thing. Why? Because even wrong model also gives you the 99% accuracy. But the improving the trust is important. And whatever the questions you are asking to the model, that is important, right? So that purpose, the heart of improving the improving the model accuracy, that is heart of, I'm just always say that imbalancing techniques, cross validation techniques, ensemble techniques. These are the things, right? And label encoding and this one hot encoding. These are the different things. These are the different things. How to improve and differ. Improving the model accuracy or means model structure. That is an that the way I said you. That deploying. See, machine learning only gives you implement that only answers prediction part. The deployment purpose, there is an platform for like an Flask and Django. These are the things that comes under the web development and application development. Means the as a machine learning engineer, you will go for the only answers. This is your prediction. That's it. And once we get the answer, no, the web developer and the application developers takes that input and pass it into the web platform. Means it's kind of server deployment and all. Are you getting, sir? Can you provide the PDF of basic methods formula which we are actually the way I have created no this 120, 110 to 120 questions. The side by side I'm creating the formula PDF as well. So I think within a 2 days, day after tomorrow, you will get update about this. Don't worry, I will share with you. I will update on portal. We cannot deliver a complete solution scientist after this course. Actually, deployment concept is different. See, means your machine learning engineer or AI engineer will not go for the means complete implementation on the workflow of Flask and Django. These are the not you will get any person to implement that, because every companies and every person that has a different roles, right? This role isn't till the predictions, and suppose if you go for the AI, there is an also prediction because huge amount of content is are there, right? It's not like an full stack development. Full stack development isn't different. It's come from the creating a data and deploying on the server. Deploying the server is, and you will get to know about the server knowledge, right? It's kind of GoDaddy hosting servers are there. No? So hosting knowledge, web designing knowledge. You are creating a data, prediction data. We expect a complete solution course. Deployment is a different thing. Here you only implemented, you have implemented and deployed only prediction part of machine learning. Means not only machine learning, even AI as well, because ANN is also there. If suppose there is a question, definitely I will ask with the camp team. Yes, sir. Don't worry about this. Are you saying that this courses don't have to deploy? Deploy means server deployment isn't different, sir. Development, that is different. I think your deployment word is kind of deploying on the servers and designing also there. No, that's why we are not implementing this new best prediction point on the web development. That is it. That comes under the full stack. Means those are in the software developer, software engineers are there. They can take the data and implement this. But if suppose there isn't kind of this one, no, definitely I will discuss with the team. Okay. Yeah, I will pass your questions to the team and they will contact with you. No problem. Yeah. What we can do after this course, because we can apply with this course and data analyst post. Data analyst can't do for deployment on the server. Data analyst, machine learning engineer, data scientist, business intelligence, business analyst, AI engineer, right? These are the things that you can go for that apply. Hope you got my point. Okay, guys, thank you so much for joining this session. But definitely, I will. Data scientist post can fresher can get? Yes, obviously. Yes, sir. Yeah. What is the practical project? Projects we are going to take the list of projects. If suppose there is an, I have to check for the list of projects from the team as well. So which projects we have to implement, and then I will show you, tell you definitely, because still the syllabus is going to cover. That's all. Thank you. Thank you so much for joining this session. See you. Take care, you all. Bye bye.